Here we go with some more homework. Using continuity. Gosh, I hope this reaches the right people, because there are definitely going to be some students that get the correct result at the end, how about that, without the correct work. So, I don't know, maybe help each other, check with your friends, something like that. Okay, so for each of the next three functions, find the constants a and b. You know, people that get this wrong, stop reading there. You need to find a and b such that the function is continuous everywhere. Start with a definition of continuity, always, as in even when I don't tell you, but for sure right now. And so what is that definition of continuity? Well, we can either do the limit as x approaches. Well, we don't have to worry about, x cubed on its own is continuous, right? X cubed looks something like that. And ax squared, I don't know what a is, but ax squared is a parabola, so that's continuous everywhere. The only place f of x might not be continuous is at this break, x equals 2. So should I use the limit as x approaches 2 of f of x is equal to f of 2, that like two-part version, or the limit as x approaches 2 from the left of f of x equals f of 2. I'm doing this at school, is equal to the limit as x approaches 2 from the right of f of x. Well, the answer is, are we worried about over here? This is like, is the y value equal to the limit? And that's actually not what we're worried about. What we're worried about is these two here. Like, are the left and right hand limits equal? Okay. Another way to say that is, we could start with that two-part thing on the left, that two-part version. But if we did, well, then we'd have to go back and break that limit as x approaches 2 of f into the two one-sided limits. Okay. Let me get rid of that. I don't want that in my solution guide. And I'm actually going to go back and put everything with a little bit more room. And maybe even in blue, because the red makes me sad. It's like it's wrong. Okay, so here we go. So maybe I'll start with if f of x is continuous at x equals 2, that would mean the limit as x approaches 2 from the left of f should be equal to f of 2, should be equal to the limit as x approaches 2 from the right of f. Okay, so, normally I don't think I'd write this, but if you're watching this video, you might need a little bit more. So here we go. So limit as x approaches 2 from the left. If I was approaching 2 from the left, I would have to use the x cubed part. Now, f of 2 is easy. This piece up here, x is less than or equal to 2, that's my domain. So I'll replace f of 2 with 2 cubed, and I'll rewrite the limit as x approaches 2 from the right of f as limit as x approaches 2 from the right of ax squared. Now, we are cheating a little bit. We're not using numeric limits. We're kind of doing stuff algebraically. So I know if I'm using 1.9, 1.99, 1.999 into x cubed, I'm just going to get 2 cubed. And so I don't know, maybe I do. I'm going to rewrite that one too. So I don't know what a is, but I do know if I square numbers near 2, I am going to get 4 instead of numbers near 2 once I do the limit. Okay. Now, I'm not really sure how to do the algebra, so I think I'll just say, it's pretty clear that 2 cubed is 8, so 8 equals 4a, and a equals 8 divided by 4 is 2. Right? So that's how I'm going to find that constant. I'm going to start with the definition of continuity up top. And then each of those pieces, I don't know if you can see what I did, but like this whole vertical column, each of those are evaluated independently and just everything falls down the line. I think that's a lot more organized and easy to follow than if you did the limits separately and then put them everything together at the end. All right, I'll get you started on the other two, but I'm not going to worry about the other parts. Oh no! It's too early for this one. Okay. So in the warm-up soon, we're going to do the limit as x approaches 0 of sine x over x happens to be 1. That's a key trigonometric limit. I better tell you guys that in class tomorrow. Shoot, a couple days early. Well, I say if you watch this video, just skip over that part and, don't even say anything. Just do like a knowing nod. So this last one is a little bit more difficult, and the reason is you have to do 2 bits of continuity. Over here, I'm going to do the limit as x approaches -1 from the left of h is supposed to be equal to h of -1. h of -1 is easy, that's 2. By the way, the limit as x approaches -1 from the left of h is also 2. And we need that to be equal to the limit as x approaches -1 from the right of h. And that we're going to rewrite. The limit as x approaches -1 from the right. And instead of h there, we'll use the symbol ax squared. That's the part of h that we would use for -0.9, -0.99, -0.999. And I think by putting in the word so, it's very clear that I combine the two 2's together. And what happens when you put numbers near -1 into ax squared? Well, basically you would get what you would get by substitution. And so we're just going to write a times -1 squared, or 2 is equal to a, and we're done. 6 periods starting. Anyway, so how are you going to get the other part? Well, you need to do basically the same work over here. But before you do that, don't use a again. You've kind of figured out that we're going to be talking about 2x squared for x values between -1 and 3. And then when you do the other work, making h continuous or inspecting when h is continuous near 3, you'll figure out what b can